Good morning, everyone. So our final review session online. Thank you for sending problems. I've got 6 problems that people sent me. So, I mean, we just pipe up if you want to ask one. But in kind of the order I received them, I got question number 56. And 56 we did the other day, I think. Yeah, but I revised it a little bit. So number 56, well, let's look at it on here first. Number 56 says determine the values of B and C such that the function is continuous on the entire number line. And they gave us this piecewise function. And as you can tell from the problem, I started with this lower left-hand section here because they told us, I mean, the top one is what? For x plus 1, that's between 1 and 3. We get that. But then the second one said when the absolute value of x plus 2 is greater than or equal to 1. So down on the bottom here, I solved that inequality, and I came up with, oh, all that means is it's 3 or bigger, and it's 1 or less. So that matches up with the, the key connection points are obviously 1 and 3. So do these two connect at 1 and 3? And what would it take for the letters B and C to have them connect? So obviously there are 2 key points, 1 and 3. So let's take the first one, 1. For 1 to be a connection point on the top one, what does x have to be for that to be equal to 1? And the answer is 0. Okay, so in the other one, I set x equal to 0. And if x is 0, then you just get, when you solve this, you just get c equals 1. So now we know c equals 1 is a key point for 1. All right. Then the other key point is 3. And when when this function equals 3, x would be 2. So looking at the bottom here on the second part, x is 2. If x is 2 and you substitute in, and c is 1, we already know that. So if x is 2 and c is 1, and you substitute in, you find out that b is -1. So yesterday what I did is I set the bottom function equal to 0, which was a nice problem, but that being equal to 0 has nothing to do with the problem. The problem is, do those points connect? So this will be continuous when c is 1 and b is -1. Then the graph will just continue and will connect. So that was number 56. Okay, let's take a look at number 61, the second one I got. Okay, we looked at this yesterday too. 61, g of x equals 2e to the greatest integer of x divided by 4. So, all right, so what does the greatest integer say? I mean, obviously, anything between 1 and 1.9 are all going to come out the same, because when you take the greatest integer of 1 anywhere up to 1.9, you're going to get 1. And so there's a connection there. But then as soon as you go to x equals 2, it's going to hop up to 2. So the point here is there are going to be hops at every integer. And then we looked at the graph. Here's the graph. And you can see the graph literally does hop. I mean, it's continuous from 0 up to 1. Then it hops up to 1. 1, to 2, we're good. 2 to 3. So when you answer this, you're going to be writing just an infinite number of intervals. 1 comma 2 in parentheses, 2 comma 3 parentheses, open. Anyway, so I think what I showed you yesterday is you could put like k comma k plus 1. Is this number 61? Do I have that? I don't know where I have it, but I think I showed you one similar to it last time. So anyway, that's 56 and 61. The next request I got was for number 48. Okay, let's take a look at number 48. Let's see, find the limit if it exists, if it does not, explain why. So then way up at the top here. All right, so you've got this piecewise function again, and obviously a key point is -2 because that's where these two things, that's where their domains end. Well, can you do direct substitution? If you plug in a -2, and you got to be really careful here because when you plug in a -2 to that top one, I mean, you're just plugging in for s. So when s is -2, s squared is +4, and then you have to throw that negative sign on. So that actually becomes -4 plus 8, -4 plus 8, so we're at 4, and 4 minus 2, 2. Okay, so the top one comes out 2. When you plug in a -2 on the bottom, you get 4 minus 8 is -4, and -4 plus 6 is +2. So they connect. So I forgot, what was the direction? Yeah, so the limit, I mean, this is continuous, okay? And we can actually find the limit by substituting on that one. So that's a quick discussion of number 48. Another request I got was number 3. Which I'm having trouble getting to. Okay, number 3. So this is one of those charts where you're supposed to fill in and you're supposed to tell what's going on here. Okay, so 3 doesn't work. You get a 0 on the top, which is okay, but on the bottom you get 0, and 0 over 0 is not calculable. So you can't put something in there, but you can play around with the limits on either side. So I don't know, I'm not going to do the calculator stuff, but if you, what is that, x minus 3 over x squared? Let me write this down. X minus 3 over x squared minus 7x plus 12. Go to Desmos. And you can see that there's a disconnect at x equals 4. We've got vertical asymptote there. And if we just factor it, we can see that, what is that bottom one? Negative x minus 4, x minus 3. And the x minus 3's cancel. That means that one's removable. Whenever you can cancel, that's a removable. but you still have the x minus 4. And so if x is 4, you've got a problem there, because that's not going to cancel, and that will create a 0 in the denominator, and that is a vertical asymptote every day of the week. So basically, what is the limit as x approaches 4? From the left, it's negative infinity, and from the right, it's positive infinity. And what's the overall limit? Does not exist. So that's, yeah. So, all right, let's go back here. So that was number 3. Let's talk about number 6. So find the graphic. Oh yeah, we have that one here. Number 6, I think. Yeah, here's number 6. So just looking at the graph, what's the, in part A, what's the limit as t approaches 0? And from the left, we're down to negative infinity again. From the right, we're up at positive infinity, and never the twain shall meet, so does not exist. And what about the limit as t approaches -1? Oh, that's fine. It looks like it's going to be the height of 0, both from the left and from the right. So you would just say, so I mean, that limit, you can actually take these limits by just looking at the graph. All right, that's number 6. Another request I got was number 88. Okay, so here, let me, that might be kind of tiny, so let me grab it. So what's going to happen here is you take the limit of 12e to the -2x as x approaches 0. Well, by the way, it approaches 0 from the left. That's really important. So that means it's a very, very, very tiny negative. So now put it in the context here. What's -2 over a negative tiny? Well, a negative over a negative is a positive. And what's 2 over a tiny? It's going to be a positive infinity. And now, what's e to an infinite power? Well, it's going to be infinity, and 12 times. So this, the only thing you could say here is the limit is, positive infinity. So that would be the way I would analyze that one. All right. So I'm out of, those are the 6 questions I received by email or text message. What else do you want to talk about?
You had mentioned difference of difference quotient or something similar to that. Could you go over that again?
I sure can. So yesterday, I think we did a polynomial, and we did a root problem. So I don't know. Let's see what's left. Let's.
This was like the f of something minus h over something or other.
Right. I'll show you what the difference quotient is. I was just trying to think of what kind of an example do you want to do one on, but we'll figure something out. So let me go back. So first of all, I do have So here's the first difference quotient we did yesterday. Yeah, I remember now. I boxed these up so we can look at these again. So did you have any questions about this first one? Well, so basically you're given a function, and let me write it off to the side. So what you're doing with a difference quotient is, and you have to know this. Whoop. Let's go back. Difference quotient. So what you have to know is that, and let me just make this a little bit thicker. You have to know that a difference quotient means yeah, that minus sign got sticky. So that's a difference quotient. And what we're going to do in the next chapter is we're going to just add on to that the limit of that as h approaches 0. So when you work on a difference quotient, you can't have that h on the bottom, because we know we're going to be trying to substitute an h in, and you can't have a 0 on the bottom. All right. So with that in mind, we went at this difference quotient, and you got to figure out f of x plus h. So that's the first thing I did up here at the top. And then, and that's no small matter. You got to do that algebraically correctly. So you got to cube x plus h properly, which you may have to use more paper to do. And then you got to multiply that by 2, and you got to subtract the x plus h. Anyway, after I've done all of that, right in here in this line, then you have to subtract the f of x, subtract the original function. So up here, the original function is 2x cubed minus x. So I'm subtracting that whole thing. And of course, what's left is all the terms that aren't alike. And you can see that you can factor out the h, and now you've got your difference quotient, 6x squared plus 6x plus 2h squared minus 1. So that was that one. Then we did one with a root. I don't know if you guys, yeah, that blue is kind of a bad choice, but so we took the square root of x plus 1, and we knew this is no sweat. F of x plus h, hey, I just plug in an x plus h. Okay, that's cool. You don't have to do a lot of calculating there. Then you got to do the f of x plus h minus the f of x all over h. And again, we have a problem. We have that h on the bottom. Well, here's where conjugates came into play. If we multiplied top and bottom by the conjugate, we had a hope. Well, we could get rid of the roots, and then the h is out in the open, and we can maybe cancel. And in fact, we will be able to, because you get, after you simplify the numerator, you get an h down there, and the h does cancel, and not simple, but there is the difference quotient. So do you want me to just make up a function and do another one? Is that what you had in mind?
I think I got it now. I was just
okay.
to make sure about what the formula was.
Yeah, and this is what you guys have to remember. This thing, I mean, all of you have to know, this is a huge thing in calculus. At the moment, we're not going to take, at the moment, we're not doing the limit, but you guys have to know how to do that. Yeah. I mean, that wasn't the prime thing we did in chapter 2, but that's where it's all kind of heading. So thank you for the question. Another question? Let's see, some other things we talked about the other day. The difference of two cubes. Remember we did that example? So a difference of two cubes, if you do, so that allows you to actually factor the difference of two cubes. Do we actually have the difference of two cubes? You have to determine that. And then you get a binomial and a trinomial. Remember that? The binomial is the cube root of the first term. And then the other part of the binomial is the cube root of the minus term. And then over here, you actually, take that term and square it, and that goes there. Take that term and square it, and that goes there. And then you take the product of the two. These two, the product goes right there. What's the product? 3 times 4 is 12, 8 to the 6, b squared. And then this sign is the opposite of that one. And then you can also do it with a sum. Same thing, same rule. Let's see, we did one here. Remember this one? We did solving by completing the square. That's a technique everybody needs to get used to. And in fact, it's so powerful that we were able to use completing the square to actually come up with the quadratic formula from the basic ax squared plus bx plus c. So those are some of the, general algebra skills that are important. Don't forget your special limits. I think you guys might be a little bit shocked at how short the test is. I mean, I'm not into, the whole idea here is not to have a marathon session, but just, do you understand how limits work? Can you figure them out? And yeah, so I don't necessarily need a really long test to do that. So what else would you like to go through? I check my messages here, see if somebody has sent something into me electronically. Oh yeah, here's a question. Are we able to use calculators on the test? No. Sorry. And you really aren't going to be at a big disadvantage because of that. I mean, sure, we've been using Desmos to check some things visually. You won't be able to do that. I mean, you can't really check that, but you are still able to do the calculations. There are not going to be some mind-bending, difficult calculations to do. So I just noticed that question here. Any other questions? Send them my way if you still do want to ask. That's fine. Otherwise, I guess we're going to hang it up. Thank you for coming. We do have a test tomorrow. I'll see you then.